I want to tell you about something that bothered me for years. Still bothers me, actually. It's an experiment so simple a child could understand the setup, yet so strange that nobody, and I mean nobody, truly understands what it means. I've spent decades thinking about it, teaching it, calculating it. Doesn't matter. The strangeness never goes away. We're going to fire electrons at a wall with 2 slits in it. That's it. That's the whole experiment. But what happens will break everything you think you know about reality. Let me start with something familiar, something that makes sense. Imagine I've got a machine gun, not a very good one. It sprays bullets randomly over a wide area. In front of this gun, I put an armored wall with 2 holes cut into it, just big enough for bullets to pass through. Behind that, there's a backstop, maybe thick wood, and a detector that records where each bullet hits. Fire the gun. What happens? Exactly what you'd expect. Some bullets go through the left hole, some through the right hole. They hit the backstop in 2 clumps, 2 distinct bands corresponding to the 2 openings. Cover the right hole, you get 1 band on the left. Cover the left hole, you get 1 band on the right. Both holes open, you get 2 bands. Simple, obvious, the way particles should behave. Now let's try the same setup with water waves. Fill a ripple tank, create waves, let them hit a barrier with 2 slits. What do you see on the other side? Not 2 bands, multiple bands. An interference pattern. The peaks and troughs of waves coming through both slits interact with each other. Where 2 peaks meet, you get a bigger wave, constructive interference. Where a peak meets a trough, they cancel out, destructive interference. This creates alternating regions of high and low intensity, a characteristic zebra pattern that screams wave behavior. You can see this in any ripple tank, hear it with sound waves, observe it with light passing through narrow openings. Particles make 2 bands. Waves make many bands, different behaviors, different types of things. So far, reality makes sense. Here's where everything changes. Let's fire electrons at our 2 slits instead of bullets or waves. Electrons are particles, right? Little discrete chunks of matter with definite mass, definite charge. They should behave like bullets. 2 slits should give us 2 bands. Fire the electrons. Wait. Watch the pattern build up on the detector screen. You don't get 2 bands. You get the interference pattern. Multiple bands, just like waves. The electrons are somehow interfering with each other, acting like they're waves, spreading through both slits simultaneously. Maybe that makes some sense if you fire many electrons at once. Maybe they're bouncing off each other, interacting somehow, creating this pattern through mutual interference. Okay, let's test that. Let's fire the electrons one at a time. 1 electron, wait for it to hit the screen, mark where it landed. Fire another, mark it, another, mark it. Do this thousands of times, firing single electrons with enough time between them that only 1 electron exists in the apparatus at any moment. Each electron hits the screen at a single point. Click. 1 dot. Definitely particle behavior. But as you accumulate thousands of these dots, something impossible emerges. The dots aren't random. They're building up the interference pattern. The same zebra stripes you get with waves, but these are individual particles, arriving one at a time with nothing to interfere with. Each electron is interfering with itself. Stop and think about what that means. A single electron leaves the source, travels to the screen, and hits at one specific point. But the probability of where it will hit depends on both slits being open. With both slits open, there are places on the screen where electrons never land, dead zones in the interference pattern. Cover 1 slit, suddenly electrons start hitting those previously forbidden spots. The electron seems to know about both slits simultaneously. It's as if each individual electron passes through both slits at once, interferes with itself, then collapses to a single point on the detector. This isn't a metaphor. This isn't approximate language. This is what actually happens. An electron, a single particle, explores multiple paths through space simultaneously. It exists in what we call a superposition of states, in this case going through the left slit and going through the right slit at the same time until the moment it hits the detector and becomes localized at one spot. Your brain is trying to reject this right now. Mine still does. How can one thing be in 2 places? How can a particle behave like a wave? But here's what really kept me up at night, the part that reveals how deep this strangeness goes. What happens if we try to catch the electron in the act? Let's find out. Place a detector at each slit, something that can tell us which path the electron actually takes. Maybe a tiny light source that flashes when an electron passes through. Now fire the electrons again, one at a time, same as before. Each electron triggers one detector or the other, left slit or right slit, never both. So the electron is definitely going through one slit, behaving like a particle, taking a definite path. Good. That makes sense. Check the screen where the electrons are landing. The interference pattern is gone, completely gone. Now you get two bands. Particle behavior. The moment you measure which slit the electron goes through, it stops acting like a wave. No more interference, no more stripes. Just two clumps of dots corresponding to the two slits, exactly like bullets. Turn off the detectors. Don't look. Interference pattern comes back. Turn them on. Look. Two bands. The electron knows whether you're watching. And I don't mean that metaphorically. I don't mean the electron has consciousness or awareness. I mean that the physical act of measurement, of gaining information about which path the electron takes, fundamentally changes what the electron does. When you don't measure, the electron explores both paths, interferes with itself, creates the wave pattern. When you do measure, the electron is forced to pick one path, behaves like a particle, no interference. This isn't about disturbing the electron with clumsy detectors. You can make the measurement arbitrarily gentle. You can use detectors that barely interact with the electron at all. Doesn't matter. If the information about which path exists anywhere in the universe, even if you don't personally look at it, even if it's stored in a computer you never read, the interference vanishes. The universe doesn't care whether a conscious observer sees the result. It cares whether the information exists, whether it's possible, even in principle, to determine which path was taken. If yes, no interference. If no, interference appears. Let me make this more concrete. Say you set up your detectors but don't record the results. The detectors interact with the electrons, but then you erase the information before storing it. You never know which path any electron took, and neither does anything else in the universe. What happens? Interference pattern comes back. You can even do this retroactively. Fire the electron, let it pass through the slits. Just before it hits the screen, decide whether to measure which path it took or erase that information. The electron somehow adjusts its behavior based on a decision made after it already went through the slits. This has been tested. It's real. People call this the observer effect, and they get it wrong. They think consciousness matters, that human observation creates reality. Nonsense. What matters is information, physical information existing in the universe. Measurement means any interaction that creates a record, that entangles the electron's state with something else in a way that could reveal which path was taken. The electron isn't traveling through one slit or the other, it's traveling through a superposition of both until something forces it to choose. That forcing happens through measurement, through interaction with the environment in a way that records which path information. Now here's where I'm going to tell you something that might help or might make it worse. There's a mathematical way to think about this that captures what's happening. Every possible path the electron could take from source to detector contributes to where it ends up. Not just the two obvious paths through the slits. Every path. Paths that curve wildly through space. Paths that loop around 17 times. Paths that go backward before going forward. Every conceivable trajectory. Each path contributes an amplitude, a complex number whose square gives a probability. You add up all these amplitudes for every possible path. Most of them cancel each other out through interference. The crazy curved paths, the loops, the detours, they all have random phases that mostly wash out to zero. What survives? Paths close to what you'd expect classically, plus interference effects between similar paths. In the two-slit setup, paths through the left slit interfere with paths through the right slit. That interference creates the pattern. But if you measure which slit the electron went through, you're destroying the ability of those paths to interfere. You're forcing the electron to commit to one set of paths or the other. No interference means no pattern. This isn't some mystical process. It's mathematics. Precise, predictive mathematics that tells you exactly what will happen in any configuration of this experiment. Does that explanation satisfy you? Does it make you feel like you understand? It shouldn't, because I don't understand it either. Not in the way you want to understand. I can calculate it. I can predict outcomes with ridiculous accuracy. But do I have an intuitive grasp of why reality works this way? No, nobody does. And here's the disturbing part. We've tested this not just with electrons and photons, but with things you'd never expect. Molecules, big ones. In 2013, scientists sent molecules made of 810 atoms through gratings and saw interference patterns. 810 atoms. That's not some abstract quantum particle. That's a chunk of matter you could almost call visible. They pushed it further. 2,000 atoms in 2019. Still works. Still shows interference. Where does it stop? Nobody knows. You want to know what keeps me up at night? Not the mathematics. The mathematics is beautiful, elegant, works perfectly. What bothers me is this. The experiment shows that reality at its most fundamental level doesn't behave like anything you've ever experienced. Not sort of different, not a little weird, completely, fundamentally, utterly alien to every intuition you've built up over your entire life. Your brain evolved to throw rocks and catch prey. It evolved in a world where things have definite positions, where objects follow clear paths, where you can watch something move from here to there. Quantum mechanics says that's all wrong. At the fundamental level, particles don't have definite positions until you measure them. They don't follow paths. They exist in superpositions, exploring multiple realities simultaneously, and only collapse into definite states when forced to by interaction with their environment. And you can't dismiss this as theoretical speculation. We've built technology on these principles. Your computer, the device you're using right now, relies on quantum tunneling, electrons passing through barriers they shouldn't be able to pass through, according to classical physics. Transistors wouldn't work without it. Medical imaging, GPS satellites, laser technology, all of it depends on quantum mechanics being exactly as weird as the double-slit experiment suggests. Let me tell you what really gets me. The experiment is simple. You can explain the setup to a child. 2 slits, fire particles, watch where they land. That's it. But contained in that simple setup is everything strange about quantum mechanics. Superposition, measurement, interference, the role of information in physical reality. Everything. I've spent decades thinking about this, calculating, teaching, and I still can't claim to truly understand it. Not in the gut-level way I understand gravity or motion. And here's what I want you to grasp. That's okay. Understanding in physics doesn't mean having comfortable intuitions. It means having accurate equations, making correct predictions, building working technology. By that standard, we understand quantum mechanics perfectly. We can calculate anything, predict everything, but we can't visualize it. We can't map it onto familiar experience, because familiar experience is a lie. It's an approximation that works at human scales, but breaks down completely at the quantum level. The double-slit experiment forces you to abandon your intuitions. You have to accept that particles can be in 2 places at once, that measurement changes reality, that the universe at its core is probabilistic rather than deterministic. These aren't philosophical positions. They're experimental facts, tested thousands of times, confirmed beyond any doubt. What does the electron do between being fired and being detected? Wrong question. It doesn't do anything. It exists in superposition. What path does it take? It takes all paths simultaneously. How does it know whether you're measuring it? It doesn't know. Information exists in the universe or it doesn't. If which path information exists anywhere in any form, the interference disappears. If it doesn't exist, interference happens. You want a picture in your head? A mental model that makes sense? There isn't one. The universe doesn't care about your mental models. The universe is what it is. And what it is at the quantum level is profoundly strange, utterly counterintuitive, and absolutely real. In 2012, researchers finally performed the exact version of this experiment I described in my lectures decades earlier. They used electron guns, slits 62 nanometers wide, detectors that could track single electrons, control over which slits were open. They followed the methodology precisely, and it worked exactly as predicted. Every bizarre feature confirmed. The interference pattern appears with both slits open. It disappears when you measure which slit. It returns if you erase the measurement. All of it, exactly as the mathematics demands. So, when you ask me to explain the double-slit experiment, I can give you the mathematics. I can show you how to calculate probabilities, predict outcomes, design experiments. But if you want me to explain it in a way that makes intuitive sense, that maps onto your everyday experience, I can't do that. Nobody can. The experiment reveals that reality is fundamentally quantum, fundamentally weird, and fundamentally incomprehensible to brains evolved in a classical world. And that's not a failure of physics. That's physics telling you the truth. Reality is stranger than you can imagine. The double-slit experiment proves it every single time. Accept the weirdness, learn the mathematics, make predictions, test them. That's how you actually understand the quantum world. I've given you the mathematics, the experiments, the results. I've shown you what happens. But I haven't made it comfortable, and I won't pretend to. The double-slit experiment contains the only mystery of quantum mechanics, and that mystery doesn't go away with more explanation. It just becomes more precisely defined, more carefully measured, more undeniably real.